Hello guys, welcome back to my channel. So today I'm going to do the last video on the GRE tunnels, land-to-land GRE tunnels. So I'm just going to make a recap for those who didn't watch the other videos. I'm going to also add the link on the links of the previous videos on GRE tunnels. I'm going to add those links on this video. So the first type of GRE tunnels we did was the GRE over IP. And we said that the tunnel was not the traffic was not encrypted. It was transported by IP, and the traffic was encapsulated but not encrypted. That was the first tunnel VPN we did. And then the second one was the GRE over IP, but we created tunnel profiles. Okay, so this time around the tunnel is encrypted, the traffic is encrypted. But it's the tunnel mode itself is in IP. Okay, tunnel is in IP mode. The third type of tunnel, the VPN we created, was the GRE over IP with tunnel mode IPSEC, which was the virtual tunnel interfaces that we created. That was last video. And again, the traffic is encrypted. Okay, but just the tunnel itself is in IPSEC mode. Okay, so the last one we're going to do today is going to be GRE over IP VPN with IPSEC crypto map, which means we're going to apply our crypto map on the physical interfaces. Okay, we're going to apply our crypto map on these physical interfaces. Okay, so that's what we're going to do today. So now I went ahead and added those devices, the R1 for site 1, router R1 for site 1, router R2 for site 2, and then the ISP router, and then the IP scheme. I'm going to use the same IP scheme as before. On the LAN side of site 1, it's going to be 192.168.10.0. On the LAN side of site 2, 192.168.20.0. The tunnel itself is going to be using the IP scheme 10.0.0.0/24, and then on the internet facing side of site 1 router is going to be 64.64.64.0/30 and 65.65.65.0/30 for site 2. Alright, so the first thing we want to do right now, as usual, is to fire up these devices and make sure they all up and running. And actually there's no connectivity between R1 and ISP and R2. Okay, so the first step here is not even done. Routing reachability between R1, ISP and R2, that's not even done. So first thing I'm going to do, I'm going to fire up these devices. Okay, so the devices are now all powered on. So we're going to try to configure reachability between R1, ISP and R2. So let's start with the ISP. So ISP, we have interface serial 0/0, no shot. I'm going to give IP address 64.64.64.1. 252/30. I think I made an error. IP address should be IP address. Okay, IP address. Okay, I know why. So interface serial 0/0. So interface serial 0/0 for ISP is going to be IP address 64.64.64.1. Okay, so enter. Interface serial 01. That's the one facing the site 2, no shot. Okay, I'm going to save that. I'm going to move to router 1, site 1. We're going to start with a loopback interface. So for the LAN side, we're going to use loopback interfaces. Okay, on site 1, we're going to use loopback interface 0. On site 2, we're going to use loopback interface 0 as well. So interface loopback 0 for slide 1. I'm going to give IP address is going to be 192.168.10.1. Zero. Okay. And then we're going to use interface serial 00, which is the internet interface inside, no short. IP address is going to be 64.64.64.2. Okay. Exit out of there. Now we're going to define the for any route destined for internet. It's going to go out interface serial 00. So we're going to define the default route on this router. IP route okay, any traffic destined for internet is going to go out serial 00. Okay, and that's done for site 1. Now let's go to site 2. We're going to do exactly the same thing. Interface loopback 0. IP address is going to be 192.168.20.1. Okay. Interface serial 0, no short. IP address going to 65.65.65.2. Okay. Then we're going to define the default route. Anything going out to the internet from this router is going to go out through serial 00. Then we save. Now let's try to do end-to-end ping. Okay, we're going to try to do end-to-end ping from site 1 to site 2. Okay, which means it's going to go through the ISP. So on the globally, we're going to try to do a ping end-to-end ping, which means we're going to ping from R2. We're going to ping 64.64.64.1. Okay. Ping is not responding. So okay. I realized that I did not do not shut on the serial 00 of the ISP. So we're gonna go fix that right now. No shut. Now let's do a ping from ISP to R1 and from ISP to R2. So let's go to R1 first. It's going to be 64.64.64.2. Okay, that's responding. That's good. Now let's do a ping to R2 from ISP. Ping 65.65.65.2. Okay, that's responding. Now let's do a ping from R1 to R2. From R1 to R2, which means we're going to ping 65.65.65.2. Okay. Okay, ping is responding. So right now we have end-to-end connectivity between R1 and R2. Okay. So the only thing is not connecting is, the only things that are working right now is LAN to LAN connectivity. That's the goal of this video, to make sure that on the LAN side of site 1 we can be able to reach the LAN side of site 2. And if we try a ping, it should fail. Okay, if we try a ping, let's say from site 1, we're pinging 192.168.20.1, which is the okay, let's just, okay, that ping is failing. Even if we source the traffic from 000, it's still going to fail. Okay, so that's the goal of this lab, is to make sure that GRE tunnel is working. So we're going to try to start the configuration right now. So right now we're going to start the VPN configuration, and again, as I showed you before, we've done this step 1 is done. Now we're going to do step 2, which is IPSEC 1, ISACAM policy, and with the pre-shared key. So we're going to start with the R1. We'll create a ISACAM policy. Policy number 10. Encryption 3 days. The hash is going to be MD5. Then authentication is going to be pre-shared. Defilement group 2. Then we exit. And since we defined that we're going to use pre-shared key, we have to provide the pre-shared key for the peer, for the remote end. So crypto ISACAM key 00 here just indicates that we're going to provide the key in clear text. Cisco 123, that's the key. Then we provide the address of the remote end, which is 65.65.65.2. Okay. Now the pre-shared key is provided. Now we have to provide the traffic. It's going to be the access list for the crypto map, as we're going to create the access list for the crypto map. Access list 100 permit. We're going to permit gray tunnel because we're going to create a gray tunnel. From host 64.64.64.2 to host 65.65.65.2. So access is created. Now we have to go to phase 2, starting with the transform set. IPSEC transform set. We're going to call it my set. Then provide the payload for the encryption. The encryption by 3 days. And we'll provide the payload for the hash. And if you don't know what hash is, it's just basically to Make sure the traffic, the data is scrambled in a way that it's difficult for to be detected. So the payload for the hash is going to be MD5. Okay, so transform set is created. Now we have to provide the mode, and we, as we said, for LAN to LAN VPN, that site to site VPN mode, there are two modes actually. So the mode transport is better for LAN to LAN VPNs, and then tunnel mode is better for multi-point VPN. Okay, so we're going to say mode transport. Okay, that's for the transform set. Exit out of there. Now I have to create a crypto map. We'll call it my map, and we give a sequence of 10. Now the crypto map is going to bind IPSEC to ISACAM. Okay, and we're going to set the set the peer. Set the peer to the other end of the tunnel, which is 65.65.65.2. We'll set this transform set to the transform set we just created. So set transform set to my set. And we're going to match the IP address that we also created previously, which is IP address 100. We just created somewhere above there. So the crypto map is created. It's not applied, it's just created. I'm going to exit out of there. Now we're going to create the tunnel interface. Tunnel 0. We're going to create interface tunnel 0. We'll give it an IP address. We're going to give you an IP address of dot 1. Okay. And in that tunnel, we're going to run OSPF. OSPF process 100 in area 100. Okay, we define a tunnel source. Tunnel source should be our serial 00. Okay, and tunnel destination is going to be the remote end, which is 65.65.65.2. Okay, dot 2. So we exit out of there. We save. Alright guys, we exited and we saved, but actually we didn't apply that tunnel. Okay, we didn't apply, as we said, we're going to apply that tunnel on the physical interface. Okay, we have to apply it now on the physical interface. So let's go in there, configure terminal. So interface serial 0/0. So we have to apply that crypto map. This is going to be my map. Okay, and once we apply the crypto map, the tunnel should come up. Oh, it shouldn't come up because the other side is not configured, but the ISACAM, we're going to see a log. Okay, so ISACAM is on for one side, but the tunnel itself is not yet up. Okay, so exit out of there and then save. So side 1 is done. Okay, side 1 is on router 1. So now we're going to do side 2. It's going to be a mirror image of what we've done. So I'm going to do it a little bit quicker. Alright, so this is the configuration of side 2. I'm going to do it much quicker. I just did it here on the part. So this IPFACE 2, IPFACE 1. Okay, and then this is the access list. It's going to be this exactly what we did before, but the IPs are reversed. Then the transform set is the same. Okay, crypto map is the same, except that the IP here is going to be the IP of the remote end, which is now 64.64.64.2. And then the tunnel interface itself, I have just, the only thing I have to change here is this IP, which is 10.0.0.2. okay, it should be 10.0.0.2. so everything else is the same. Everything else is exactly the same. I'm going to just copy paste into router 2. So I added the configuration on router 2, and now we can check, see if the tunnels are up. Show crypto is Upcom Security Association. Okay, tunnel is up, that's good. So if we do show crypto IPSEC Security Association, okay, so we can see exactly that the tunnel is kept alive with the interesting traffic that we defined with ACL from 64.64.64 to 65.65.65, and we have the gray tunnel. Okay, this is the port number for gray tunnel. And we can also see that there is encapsulation and decapsulation going through the tunnel, okay, which means the tunnel is actually up. And we can see, what else can we see? We can see that the inbound and outbound security associations are using transform set. Okay, they're using using transform set that we created, and okay, and then they're also in the transport mode. Okay, we created, remember the tunnel was in transport mode, so that was exactly what I was looking for. And if we do show interface tunnel 0, okay, we can also confirm here. Okay, tunnel is in transport mode. Okay, and it's a gray over IP tunnel. Okay, so there's the last test we want to do right now is to make sure that there is reachability between the LAN sites. Okay, that was the goal of our what we wanted to set up to do. So let's try to do a ping from 192.168.10.0 to what am I doing? Okay, all right, let's try to do a ping from 192.168.10.0 to 192.168.20.0. okay, let's try to do that ping. I fired off Wireshark by mistake, so I'm gonna do a ping 192.168. Okay, I'm on site 2, so I'm gonna ping 20.1. okay, ping is not working, and the reason ping is not working is because if we do show run interface tunnel 0, okay, so tunnel 0, that's our gray tunnel, is running OSPF. Okay, now let's check if OSPF is running, is being injected on the tunnel, on the loopback interface, which is our LAN site. Okay, so it's going to be show run interface loopback 0. Okay, so the reason we cannot ping the LAN sites because we need to inject OSPF into the loopback interfaces. Okay, that's what I'm going to do right now. It's going to be configure terminal interface loopback 0 IP OSPF IP OSPF process 100 area 100. Okay, that's all we need to do to save. Do the same thing on R2. Show run interface loopback 0. Okay, it's not OSPF running on this loopback interface, so we have to inject OSPF interface loopback 0 IP OSPF process 100 area 100. Okay, then we save. Now if I do show IP route OSPF, show IP route, we're not seeing OSPF routes. Yeah, so what happened is I think when I was creating the tunnel on site 2, I made an error. I copied maybe wrong IP addresses, and for that reason the tunnel didn't come up. No, the OSPF was not working, so probably something was wrong. I haven't troubleshooted completely, but I had to recreate the whole app. So right now we can ping from site to site, from one site to the other we can ping. So right now we're on site 1. So if I do a ping to 192.168.20.1, which is on site 2, okay, don't need to source traffic from anywhere, just default ping, it works. Okay, if I do a ping, the reverse ping should work as well. Ping 192.168.10.1. okay, that one works as well. So basically the lab is completed. I will try to troubleshoot further because this is a completely different lab that I created to make this happen. So yeah, but it should work exactly as on this diagram. And so thanks very much for watching today, and next video we're not going to talk about VPNs anymore. For now we're going to I haven't prepared the next video yet, but this is the end of this video today, and thanks very much for coming to my channel. And if you're new, please consider subscribing, and talk to you next time.